Hello and welcome back to another one-day build, and what this was creating some wound counters. So what these are is designed by a designer called Carl Phobit. I downloaded it off Thingiverse, and the general principle is you spin the dial, it counts your wounds upon a game. We just dug out some old Magic the Gathering cards, and the reason I'm showing you this is actually from this design under the Creative Commons license. I'm free to remix it. So one of the things I wanted to do was play with it on my Ultimaker and turn these into two colour designs. So have the dial with, if we can get it to focus, having a dial with the numbers on. There we go, get it into screen. So the numbers are one colour and the skulls are another. And what I'm going to jump to now is just the process of how I cut it up and how I took it apart. So what I used to cut this up was Tinkercad. And the reason that I used Tinkercad when doing this is because it's free software, it's easily available online, and it allows me to process STLs. So on Thingiverse, the file type you download is an STL. And what that is that's a point cloud of data, and it's designed because it's quite small, so they're very easy to send, they're very easy to share. That's why sites like Thingiverse exist. But the problem is those models are quite hard to adapt, and that's what I'm doing here on this. If I were to take it into a more professional CAD package, perhaps something like a SolidWorks, I'd run up against the challenge of SolidWorks wanting to take all that data and then turn it into features and run a feature analysis. And quite often that errors and quite often that falls apart. So actually, if I want to do some simple processes of cutting apart, filling in areas, perhaps chopping the dial in half, building a new dial like you can see on screen, it's far easier to do that in a simpler CAD package. So similar in the past when I've talked about Mesh Mixer and how I use that for organic forms, I use Thingiverse when I want to actually create known shapes and sizes. So the nice thing is, as you see when I input the data, you have dimensions and measurements. So like I'd recommend Autodesk's Mesh Mixer if you were playing with organic forms, I'd recommend Thingiverse if you want to create sizes and forms that you know the size of. So when I created the dial, the centre pin, I made it about 6mm. And now what I'm going to do is go back and just talk you through some of the iterations that I did to create these wound counters. Back to the original video, the first thing I wanted to do was actually try to fill in some of the gaps. So what you're going to see, if this will happily focus, is that the filling in on the eyes on these is actually 1.5 millimeters off. So if you're creating a form, if you're creating two shapes for a dual extrude printer, what you actually need to do on the software is load in both of the STLs and then align them together. What that did was that drove some of my design decisions. So it drove a decision like taking the center out the dial and grab a focus, taking the center out the dial and making it so it goes all the way through. The reason for that is that both of them sit on the build plate. So both the element 2, the silver element, element 1, the center dial and the numbers sit on the build plate. So I don't have anything floating in space. It makes it easier to align. And the dial was the easier of the two components to align because they were both a 30mm cube. The problem that happened with the skull face initially, and what you'd need to do if you want to print this, because I'll upload this mix back onto Thingiverse, is that what I did was I placed a disk of material in Thingiverse into there and then used the skull pattern to remove the extra material, creating a negative, which creates the skull, basically. But the problem was, once I'd done that, I needed to remove this top square so you can see the numbers. And when I did that, that altered the footprint. So the alignment of the two parts in the X-plane is fine, but in the Y-plane, you will need to move the two elements by what is 1.5 millimeters. So once I'd got that down on the first iteration, I moved on to the second, printed out to scale, and my first measurements were off. That's far too wide. It was such a big numb gap. I actually didn't measure it, I just guessed at it and printed something out for a quick go, which then led to me slimming it down on the what will be the second iteration, but still it's not great. The letters are about 1.5 mm, so finally third iteration got it to where I want it to be. I've got a really nice slim wound counter, and this one was just in the materials I had on the printer, so green and glow in the dark. But as you'll notice, it does pop apart. The joint isn't really great, it doesn't stay together, so I started experimenting with that. The next one I did, I made the interference fit a bit tighter, and to be honest this one's a bit too tight. Put in more of a gap, it works okay, but it was too tight for what I wanted it to be. So what I tried to do was be a little clever and put a clip in it. So looking at the PLA on this, hopefully we can get it, you can see I put a clip in, and then on the underside of this piece I put a recess for it to attach in. Now this was the first test, it wasn't really successful. It doesn't actually press through, and it's something I do want to work on. But following that I tweaked it a little, played with materials, and now I've got a set that hold together and will print in multiple colours, so you can have nice black and white, green and black, or silver and black. The only thing that was a challenge with them was if you use some of the transparent materials, you can see that central hub slightly. So looking at this one that I used the white dial on for clarity, because the orange is transparent you can see through it. But it's been quite a nice fun project. Hopefully in the description underneath I'll be able to link you to Thingiverse and you can download this and give it a go. But for a 10 wound counter, it was a fun project, it was great fun. And what I really wanted to show you is how you can use free software like Tinkercad to process STLs in quite a basic way, but still having some decent dimensionality, so you can do iterations like this in order to get a tight, fixed outcome that you want where the parts don't fall apart. So thank you for watching, and please keep designing every day. I hope you'll look at some of the other videos, and I hope to speak to you again soon.